Welcome back, everybody. So a couple things just to mention off the bat. So next week we have our second exam. We're gonna finish off the chapter 2 material. Hypothetically, as long as everything goes according to plan, we're gonna finish it on Thursday. Then on Tuesday, we'll finish up any last screening questions and spend the rest of the time reviewing. And then we will move on from there. So same kind of gist for the next exam, like roughly 8 to 13 questions. If it's 8, there's probably going to be a few with multi-parts. If there's 13, there's probably going to be less multi-parts. But I promise you, it will be doable within an hour and 20. So it's kind of same rules apply. But either way, we'll go ahead and get started with this bit of material, which is section 2.4, which is on modeling and investments. So, as per usual with this course, we're just trying to introduce the concept. This thing can get a little more complicated as time goes on, but mathematical modeling is a very, very useful tool. It's a great field to be in, and that's why this probably when I declared math major that one of the things that people would ask was and I had to ask the advice was what do you do with a math degree? Which the correct answer is nothing, right? I'm just kidding. Unlike a physics degree or whatever, where there's or a computer science degree was a definite end goal of where you're going to be. Mathematics is getting a math degree is far more open-ended. And one of the things that you can get really good in is mathematical modeling. So taking real life situations and trying to model them with mathematics. There's actually a whole section of mathematics called optimization, trying to optimize things. There's a really cool thing. It was a problem that one of my friends they took that route, which is the far better route to do it for mathematics if you want to make money. One of the questions he was showing me was, you work for a detergent company, you make soaps and stuff, and the same compound gets used in your dish detergent as it does in your laundry detergent. How do you maximize profit given all these constraints? And you take in every piece of information, and then you make an educated guess on what will be most profitable. That is what we're going to start doing. We're not going to get into nearly that much detail because we can only really work with one variable, but this thing does extrapolate. So as a small little sidestep, I want to do a little review of linear equations. So before, most of our equations were things like this: x plus 7 equals 12, or 5x equals 40. And so these are what we call one-step linear equations, because it only requires one step to solve. You have to subtract 7 from both sides on the first one to get x is equal to 5. Whereas with the second one, you've got to divide both sides by 5 to cancel out the 5s and get that x is equal to 8. So that was what we did before. Those were called single-step linear equations because they only required one step of work to finish them. Now we're going to start working with multi-step. So now we're going to have things like 3x plus 5 equals 26. So this is going to require two things. And the convention, and we're not going to get too much more complicated than that, but this can get more elaborated upon if we'd like. But this whole weekend was setting up my son's birdie. I was up until two in the morning, making his decorations on Saturday. And then on Sunday, I was up until one or so, getting things back in place. You can't really have expensive stuff out if you're going to invite toddlers. They're going to just run into it and cause damage. But sorry about the yawning. So for this one, the general consensus is try and work outwards towards X. Like get rid of the things that are furthest away from X first. So that +5, that 3 is really connected to the X. That's right attached to the hip. So that 5 is what we're going to take care of first. We will first subtract 5 from both sides. And that cancels it. And then 3x is equal to 21. And now we do the second step, which would be dividing by 3 to get the x by itself. And get x is equal to 7. And the thing I love about equations is that you can always check your answer. If you plug in 7 into the original equation, you will get a true statement. 3 times 7 is 21, plus 5 is 26. So you'll get 26 equals 26, which is a true statement. Let me write that down instead of just saying it out loud, just so you can see it. You don't need to write this down. This is what we do in our head or on our calculator. So 3 times 7 plus 5, does that equal 26? That's 21 plus 5. Does that equal 26? Yes, it does. We get what we call a true statement. That's how we know we solved it correctly. If we got 5 equals 26, that's not a true statement, meaning that we made some math error somewhere along the way. So that's the one thing I love about equations is you can always check your answer. What may come up, what you may be thinking is, well, why can't I divide by 3 first? And I want to show you the classic mistake. Don't write this down because this is incorrect. 3x plus 5 is equal to 26. Students will want to divide by 3, but that's not dividing by 3. That's dividing one part of the left side by 3. If you really wanted to do it that way, you would have to divide the whole thing by 3. And so it's not wrong to do that. You can, but it's going to make things more difficult because now what we're going to have is 3x divided by 3x. Sorry, 3x divided by 3 plus 5 thirds is equal to 26 thirds. And now we've got fractions. And we don't really like, I know fractions are scary, right? They're not the nicest people around, but they're still people like you and me. So like we can deal with them. We can deal with them. But if we don't have to deal with them, might as well just avoid it, right? Trying to avoid working with the shift supervisor who always takes forever to close. Still, LG, still remember her. Great, very, very fun conversations, but with everyone else, I would get out at maybe 11, 12 at the latest. I would get out at 1 during her shifts. Deliberately saying, can I please not be with LG? So 2-step equations, you can go even further. You can just, but the idea is to try and get rid of everything away from X first and work your way inwards to solve for the last one. So I want to do 3 examples. Solve, and we're going to just do them as they, because we can do them all in kind of rows or columns, excuse me. You don't need that much space. So the first one, A, is going to be 2x plus 1 is equal to 15. The second one will be 13 minus 7x is equal to 27. And the last one will be 52 equals 61 minus 0.25 n. So I'd like you guys to do the first one on the left side. I'll slowly fill in details. I have the answer to the first one if you'd like to check your work, but if you're still working on it, continue to do so. I don't expect you to do it as fast as I do. Doing this for a long time. The second one. What's the first thing I do? Minus 13. Very good. If you're ever uncertain, just try something. What's the worst thing that happen? You erase it? It's the worst thing that can happen. Have to erase it. So yes, that is a positive 13. And that's not attached to the x, so we want to get rid of it first. So to undo that positive 13, we'll have to subtract 13. So we'll subtract 13 from both sides. Must have had an obsession with 7 when I was doing this. So negative 7x is equal to 14. And then now that we've got the x by itself, now we can divide, and we'll divide by negative 7. Cancels it there and get x is equal to negative 2, which you can use your calculator for if you can't, if you don't want to do it in your head. I'm fine either way. Last but not least, this one, just because yes, it's got a decimal in it. That's not something to be scared of, though. A decimal is just a number. So we'll take care of that. We want to get rid of the 61 first, since that's a positive. We got to undo it with a negative. So we'll subtract 61 from both sides. And that cancels it on the right. 52 minus 61, that should be negative 9. Is equal to negative 0.25 m. And now we can divide both sides by negative 0.25. To cancel it on the right and get that our final answer should be m equals 36. Yes.
Is it not? I got the same answer as you, but I did it different.
How did you do it?
I did minus.
Did you add 25 m to the other side?
So I did minus 52 instead of 61, and then I got 9 over.
Okay, so 52 equals 61 minus 0.25. I'm glad you bring this up because this is kind of this is a classic mistake that students make. So I want to show you. So yes, you can subtract 52 from both sides. But when you do that, the left-hand side is now 0. So you get 9 minus 0.25 m. And so in order to solve this, we need to, they're not on the same side, they're on the same side. So in order to solve for it, you need to have like m on one side of the equation and the variable and the number on the other. So you can still solve it. You could either subtract 9 or you could add 0.25 m to both sides. Either way is fine. But ultimately, at the end of the day, we want the variable on one side, the number on the other. Okay. So we get 36 equals m or m equals 36. Either way is fine. I believe like the reflexivity is the really fancy hoity-toity term that mathematicians like to use of saying that the equal sign is reflexive, meaning that a equals 2 is the same as 2 equals a. Like you can rewrite it as the same. Yes.
How do you get 36?
So I divided both sides by 0.25. And you can do like the only reason why I know that how to do that in my head is that 0.25 is 1/4. So what I did in my head is I was like, this was negative 9 divided by negative 1/4, and dividing by a fraction. If you do not know, it's the same thing as flipping and multiplying. So that's negative 1 times 4/1. And then I get 36, but you can absolutely use your calculator. So let me see. So oh, you accidentally did my set. They're right next to each other though. So if you do like that probably was the easy mistake to make. Does that fix it?
The negative sign is this one underneath the side.
Yes.
How do you get -2?
So 14 divided by 7 should be 2, but it's a -7, so you have to have a negative there. Positive divided by.
14.
Oh, excellent question. So I'm not subtracting 7. I'm dividing by -7. Yes. I realize that makes it look confusing. Absolutely. That's not subtracting 7 from both sides. That's dividing by -7. All right. So the reason why I bring these up, and so in case you were wondering, did I tell you why it's called a linear model? Or sorry, did I tell you why it's a linear equation? So we don't get time to talk about them, despite them being very, very fun to draw and everything. But a line can be represented by the form y equals mx plus b. Any line can be represented that way. So y equals 7x plus 5. That is a line with slope 7 and y-intercept 5, and so on and so forth. That, like, you don't need to write this down, by the way. This is just, sorry, I should have mentioned. So every line can be represented that way. And so you notice the right-hand side is number x plus number. And that's what all these equations are. They have number x plus number, or number x minus a number, or number minus number times x, or a variable, whatever it is. So they are line equations, which we rewrite as linear equations. That's why it's called a linear equation. Some really fun stuff about like how lines came, like how we figured out how to graph lines and stuff. That has to do with Rene Descartes, very famous philosopher, and all that other stuff. If you want to know more about math history, it's a very fun area. But sadly, we don't have as much time for that. So linear models. A linear model is a mathematical model where the amount of increase slash decrease is fixed over time. Over time, or over whatever variable you are involved with. So like maybe it's talking about like profit, in which case it's not over time, but over quantity. Like you get more profit the more things you sell. So over quantity in that case, but a lot of times it's over time. If the total increases, we call it linear growth. And if the total decreases, we call it linear decay. And so as a as a kind of informational item about this section, if you're able to find the answers to these types of problems without setting up a linear model, I will still give you full credit. And I'm going to show you how you can figure it out without using linear models, but I'm also going to show you how you can use linear models to solve these problems. So let's solve the next problem without using a linear model, and then we'll talk about how you can make a linear model. So, example. Amy's piggy bank has $90 in it. she plans to add $6 per day. How much will be in the piggy bank will be in the bank after 20 days? This is one of those problems you don't necessarily need to set up a model to figure it out. And don't worry, I'll show you the model formula in a little bit. Oh, so sorry. Don't blame me, blame my son. So I'm going to solve it without a linear model. Solution without algebra. So solution without algebra. So it has $90 in it, and it's going to be $6 each day. So, yep, exactly right. So final amount will equal starting amount plus the $6 per day for 20 days. Starting amount is $90 plus 6 times 20 days. And that gives you a total of $210. And you can solve it without algebra. You can just do it by logic, by deducing what's stated and figuring it out from there. That is not wrong to do so. Sorry. If that was on your exam, and you did that, I give you full credit. But now we can show you how to do it with a linear model. So the linear growth / decay model. And I'm going to write so I could write it the way that the book writes it, but I find that it makes it a little more complicated than it needs to be. So what it is its total is equal to a constant plus or minus. I'm gonna color code the plus or minus. So plus or minus the rate of increase or decrease times quantity. So it's a constant, so it's just a number plus or minus a rate of increase or decrease times a quantity. Constant plus or minus a number times a quantity. A rate would be a number, like miles per gallon or dollars per gallon. That's a rate. Or feet per second. That's a rate. So when it's a plus sign, it's going to be linear growth. When it's a minus sign, it's linear decay. Why would it be called linear growth if it's plus, or linear decay if it's minus? We'll see an example, it's best seen through the example of why that would be the case. But in the previous example, So that's kind of that's the formula in words. Now we're going to rewrite that previous example in linear terms. So in previous example, we had total money is equal to the starting amount plus the dollars added per day times the number of days. So the formula that I've kind of like circled around with a squiggly line in purple, that is a generic version of it. But if we're going to apply it to this specific situation, instead of total, it's the total amount or total money. The constant is your starting amount. The rate is the dollars added per day, dollars per day. That's a rate. And then the quantity is the number of days. So to write it as a linear model, I'll slow down for a second. To write it as a linear model, we need to have variables. I need to wake up. Been yawning like since 6 this morning. So we need to define variables. Let P, and you can use whatever variables you want. So I'm going to let P equal the money in the piggy bank. And T represent the number of days. You could just as easily make M equal to your money and D equal your days, your number of days. It doesn't matter what your variables are as long as you know what they are. So the linear model would be P, the total money in the piggy bank, is equal to 90, your starting amount, plus $6 per day times the number of days. So 90 plus 6T. And the reason, so this is a linear growth model because it's a plus sign, because every day that goes by, the number is going to grow in value. After one day, you're going to have 96. After 2 days, 102, 108, 114, and so on and so forth, growing each and every day. So it's a linear growth. And it's linear because the rate at which it's growing is fixed. It's always growing by 6 each day. It's the same amount each day. That's why it's linear. If it changed, if it got more and more over time, it would be a different type of model. It's
Times T, or can we just put the T?
6T is what I would prefer. I was just, yes, no, I would prefer you write it as 6T. That's your linear model. And the great thing about having a linear model, instead of doing it without algebra, is now you can answer more questions about it, like that might be a little more difficult to do without algebra. So to put the previous problem in math notation, it's saying find P when T is equal to 20. So in math, previous problem was asking find P when T equals 20. Part of my goal in this class is is for us to be able to take in words and write it in mathematics and vice versa. So being comfortable working backwards and forwards with mathematics. So if we look back at that previous problem, it said there is, don't worry, I'm coming right back to it if you haven't finished it. It's saying she adds $6 per day. How much will be in the piggy bank after 20 days? How much will be in the piggy bank? What is P? How much will P be after 20 days when T is equal to 20? That's what that question is asking. we can rewrite a English sentence in terms of mathematics to simplify it. Depending on your definition of simplify, right? I like it much more in math form, but I'm not everybody. Let's look at some examples of setting up these types of questions. As you might expect from this section, there's going to be a lot of word problems because we're trying to model real life.
Are we creating?
We're going to be creating the equation and then also using the equation to solve problems. So example, a catering company charges a flat fee of $410 plus $55 per attendee. So you're giving the people the steak and the fish and the chicken option. That's why it's $50, $5 per attendee. Or you can be like me and say you can deal with either, you can either do chicken or steak. I can't spend, like, catering adds up for a wedding. Sometimes I feel like they're just charging extra for the wedding just because it's a wedding, but I was a grad student at the time, so I was just wondering if we could do ramen instead. And everyone just eat ramen. That'd be a much cheaper alternative. But no. So, and of course, this isn't, just so we're clear, this is not perfectly real life because they're not going to charge a $410 flat fee for a catering job of like 10 people at an event. This would be for like more like a 15 to 60 person event. So there's of course, there's way more variables that go into this, but you can do a very basic thing that they, like, if you ask them how many people are going to be at the thing and you say roughly 40 to 50 people, they'll tell you that flat fee, and they say, and then we charge this amount per guest. So this, we can't perfectly model real life, but we can actually somewhat represent it. So part A is write a model for the total cost C of an event with N attendees. So in this context, in this problem, they're going to give you the variables they want you to use. That's not always the case. Sometimes you're allowed to write whatever variables you want. And when it comes to your homework, this will be, I believe it's case sensitive. So if you use a lowercase c instead of a capital C, it might mark it as wrong. If that's the case, just let me know and I'll give you full credit back. That's an easy mistake to make. And it's just a variable, so I don't think you should be marked down for choosing a different variable. So if it asks you to write a linear model in terms of C and N, you accidentally use a capital C instead of a lowercase c or whatever, just let me know and I'll give you full credit back. Part B is going to be if the cost of catering was $5,085, how many people attended? And the cool thing that comes up to like the cool thing that this extrapolates on is later on you can ask more complicated questions. Like maybe it says that it's $55 per attendee over the age of 12, and then it's $30 for each kid under 12. For each attendee under 12. And then you have a 2-variable equation, and then that we get way more fun stuff that we can ask. So part A. So we've got that equation. Total equals a constant plus a rate times a quantity. So the total cost kind of gives away the fact that the C should be the total. So C should equal a constant. What thing is a flat number? The flat fee. I gave it away. But the $410, that is going to be the thing that is fixed. That doesn't change based on the number of attendees. That's always going to be the same amount. That is constant. That is fixed. $410 plus it's $55 per attendee. That's your rate. So it's $55 times the number of attendees. Without even realizing it, we've set up a unit conversion. This 55N converts the number of attendees to dollar amounts. Because it like just as an aside, it's $55. You don't need to write this down per person for one person times the number of people. The peoples cancel and you get straight up a dollar amount. So you're doing unit conversions even though you don't realize it. But anyways, that is your formula. That is the catering formula. That will figure out how, based on how many people are attending, you will find the total cost using that formula. Any questions on that? So your total cost is equal to your flat rate, which is $410 plus $55 per attendee. So 55 times N. That is part A. Part B says if the cost of the catering was $5,085, how many people attend? So we have to convert that into mathematics. Is that saying that C is equal to 5,085 or N is equal to 5,085? C. And there's several ways we can be sure of that. First off, we know that C is measured in dollars and N is measured in people. So since that says $5,085, that's a dead giveaway right off the bat. But the other thing is it's saying if the cost was, so cost C was equals 5,085. So here in math, it's saying if C is equal to 5,085, what is N? That's the math version of that statement.
So would it be just the same thing as table 55 or 50, 85 replacing C?
That's correct. Exactly right. We're going to use our equation to solve for N. So we've got if C is equal to 5085, so 5085 is equal to 410 plus 55N. And that's a linear equation that we can solve. We no longer have two different variables. We just have one variable, N. By the way, this just brings up a good point. So this type of material will probably show up on the exam in some way, shape, or form. And so what if you don't get part A right? Then you can like if this is a two-part problem, you need part A to answer part B, right? If it's a case where that happens on an exam, and you can't figure out part A, make something up for part B and then solve that. Do you see what I'm saying? So like, if you couldn't figure out A, just make up an equation where you can solve for the variables so that I know, like, because then you can give you full credit. Does that make sense? What I'm saying? Because I like, or if you get part C wrong, part A wrong, I will still give you full credit if you solve part B correctly using your incorrect answer. Does that make sense? So don't feel discouraged if you don't get part A right, like you can't get part B right. I give full credit if you answer part B based on your part A. That's why if this is a problem on my exam, I usually say based on your answer to part A. But that statement there says like use your answer for part A. If you like and solve it. If you get it right based on what you had, I will give you full credit. So, and if you can't figure out part A, just make something up and then solve for part B. So this one, though, we can solve it. We want to solve for N. So we got to subtract 410 off first. And when we do that, 410s cancel. 5085 minus 410 is 4675. Good. Equal to 55n. And then we'll divide both sides by 55 to get the n by itself. Canceling it on the right-hand side and getting n is equal to 85. And so the question is, do I write my answer as n equals 85 or do I say 85 attendees? The answer, so I would agree with you, but since the problem says what n is equal to, we can leave it as is.
So we make it our own.
Yes, if you make your own variable, and so here's the thing. If you had said at the very beginning, let n equal number of people, then you could say n equals 85 and I would give you full credit. If you don't say what your variables are, or if they aren't explicitly given in the problem, then you need to say what n is. Does that make sense? The way I like to think about it is if like when you're writing your work, you want to see be able to present it to a fellow classmate, and they should be able to understand your work just by looking at it without you explaining it. And so if you just write n equals 85 and say so what does n mean? So if it's told in the problem, like this one said, that n is the number of attendees, you just can box it in. Or if you have to create your own variables, then you need to say what it is, or at the very end, write down 85 attendees.
For part B, we have to have both of those, the one in quotation, like the actual sentence and the problem solving.
Nope, either one is either or. You could say 85 attendees, or you could say n equals 85, and I will give you full credit.
Oh, no,
Oh,
so you know how you did like if C equals, right, not for part B. So we have to do both of those, right? Like actually solve it and then put the question.
absolutely not. No, great question, great question. You don't have to write the if C equals 5085. That's for our notes and for our understanding of how to convert it to mathematics. If this question was asked, you could start right here and call it good. And even setting up the equation, even if you don't know how to solve it, setting up the equation is worth partial credit to me. Like that, this problem, if I was to give it a point total, I'd probably give it like maybe a 5 or let's say a 10-point total. The part B would probably be worth 4 points. Setting up the equation would be worth half the credit. So, any questions on that? Any other questions rather? Yes.
For last example,
Mhm.
I got P is 2, is that correct?
E is equal to 210. Yes, that should be correct. Yes, absolutely. Good, good. So, another example. The company V-Haul with V-Hauls with a Z rents out moving trucks for $1,000 plus 20 cents, so $0.20 per mile. Part A is how much will you be charged if you travel. Someone give me a number between 500 and 10,000. Wait, how big is the United States? Like, is it 15,000 miles wide? I don't remember.
Oh.
It doesn't matter. Someone give me a number. 800. 800, and I want to make it less nice than 800, so I'm going to do 826. How much will you be charged if you travel 826 miles? And then part B says Phil has budgeted $1,500, so $1,500 for traveling expenses. How far can Phil move? Which is kind of a terrible question. Like, if you can't move to where you need to go, kind of SOL. So why would you even bother? But so he's just trying to look at so Phil's trying to look at how far he can move within his from his home to get a new job. So in order to like part A, we could probably solve just like we did with the piggy bank, right? 20 cents per mile times 826 miles. That gives us the total charge in miles plus $1,000. We're all done. Part B, you could solve without algebra, and I will still give you full credit if you solve it without algebra. That's fine with me. I'm not going to mark you down for figuring it out a different way, as long as it's mathematically valid. So, but I'd like to do this with algebra, so I'm going to say first make a model. And once again, this is a linear model, and the reason why I keep mentioning that is because we're also going to talk about exponential models. But this is a linear model because the amount that it's increasing the total cost by every mile is fixed. It's 20 cents every mile. It doesn't change. It's not 20 cents for the first 20 miles and then 60 cents for every mile after that. This isn't Southwest Gas that we're talking about, which has been insane. If anybody's been looking at their gas bill, it's like more than double from last year for the same amount.
Right.
Yeah. Yeah.
I go to-
No, like for sorry, not
Oh.
gasoline,
No,
but
oh,
like gas for your home
Oh, yeah.
and things like that. Like I just looked at my bill and it was like twice as much, despite being I actually used less gas this February than I did last February. So, but anyways, I'm not bitter. So the thing is, the difference between this problem and the previous problem is the previous problem told you what the variables were supposed to be. Here we have free reign. We can make the variables whatever we want. So what do you guys want? What are the two kind of different variables in question here?
The total charge in the miles.
Exactly right. The total charge for the rental and the number of miles traveled. So let's use a variable for one of them. It doesn't matter what you use. What do you guys want to use for total cost? C? C is fine. V is fine. A puppy face is fine. Whatever you want to do, but let's do C equals total cost. And when I'm looking at this on an exam, if you labeling them, I don't need this to be a full statement or anything like that. You can use abbreviations. I don't need you to be like writing it out in full detail. You could just write C equals money, and I'd be fine with that. As long as it's defined somewhat that you know what it means, and it's somewhat understandable. And so then what variable do you want for the number of miles? M. That's what I would choose. Let M equal the total number of miles. M, not N. M equal miles. Number of miles or whatever you want to write, as long as like it does not need to be like it's just chicken scratch essentially. But you could, if you want to write a formal statement, you're also welcome to. Let thouest variable C equal the total cost of our traveling. And like you could do that if you wanted to, but it's not required. Total cost. So what would be our model then? So total equals constant plus a rate times a quantity. So this would be C equals the flat rate of $1,000 plus 0.20 M. So part A is saying how much will you be charged if you travel 826 miles? Are we solving for C or M?
Oh, we see,
Because M is going to be 826. Yes, so you're going to be saying, what this question is asking in mathematics is, what is C? How much will you be charged? So what is C if M equals 826? So C is the unknown, equals 1,000 plus 0.20 times 826. And luckily, C is already by itself. So we don't need to do any solving. We just need to simplify. So 0.20 times 826 plus 1,000 is 1,165.2. So C equals 1,165.20. And technically speaking, I don't need to write the $sign, technically speaking, because I've already defined what C is. C is total cost. I mean, I didn't specify that it was in dollars, so that could be in euros or pounds or whatever, but it's fine with me to say that that's going to be the answer. In stark contrast, part B is asking kind of in the reverse order. It's saying my total cost is 1,500. That is the total cost of my trip. I can't go higher than that. How many miles? So this one is asking, what is M if C is equal to 1,500? That's what part B is asking. So we're just going to replace C with what we with the number portion. So it's 1,500 equals 1,000 plus 0.20 M, or just 0.2 if you want to. It's not wrong to write it either way. So to solve for this, we solve like any other linear equation we've been dealing with. We get the variable by itself, subtract 1,000. That cancels it on the right. We get 500 is equal to 0.2 M or 0.20 M. I'm fine with either. Like the 0.20, that 0 is unnecessary, but it keeps it in the form of cents. And that's what reason why I'm writing it, but it's not required. 0.20. Cancel it on the right and get that M is equal to 2,500 miles. And since I've already stated what M is, I don't need to write it down. I don't need to write down 2,500 miles. It's clear from my information that M is what M means. So I can travel across the country. Granted, that's my moving expenses total. So like, I guess I'm not stopping for any food or any energy drinks. Apparently not. It's true. It's the best part of any road trip. You got to have some good snacks. Go to Sprouts and get those gummy bears in bulk. If you haven't had the Sprouts gummy bears, they are great. I don't go to Sprouts very often, but for the gummy bears, I would die for Riley. If anybody remembers Inside Out, I would die for Riley. I would die.
There's a new one coming out soon too.
Yeah, I'm excited. It's one of my favorite Pixar movies. Okay. So I get sidetracked with fun stuff. Okay. Any questions on linear models? The other natural one would be an exponential model. So an exponential model, a definition. An exponential model is a mathematical model, just like the others. Where the amount of increase / decrease escalates over time. So it's not a flat rate. It's not 5 cents per mile. It's like 5 cents for the first mile, then 10 cents, then 20 cents, then 40 cents, then 80 cents, and so on and so forth. And it keeps increasing each new quantity that you add to it. And sadly, this one you can't write in without writing in mathematics. So the formula is as follows. Y equals A times B to the X, where Y is the total amount, A is equal to the initial / starting amount, and B, I'm sorry, I'm writing this quickly. Slow down. You don't think I'm sorry? Now, during quarantine, I was teaching remotely, and it was a frequent comment made that I had the fastest handwriting of the West, you know. So I can write quickly. It's just an anxiety response. Too much pressure to be writing and talking at the same time. So Y is the total amount. A is the initial or starting amount. It's basically your version of a constant. Yeah, like it's the analog of a constant in the linear model. B is the growth rate. Growth rate, if B is greater than 1, and it's a growth decay, or sorry, a growth rate, and it's a decay rate if B is between 0 and 1. That right there is 0 less than B less than 1. That means that B is between 0 and 1.
So it's like 0.
Yes, 0.5, 0.2, 0.7, anything like that. That would be a decay rate. And X is equal to a quantity, typically time. So you've actually already encountered an exponential model. You've already dealt with them with the compound interest formula. The compound interest formula is an exponential model. It's an exponential growth. If you think about it, just as an aside, you don't need to write this down. So I'm writing in red. A is equal to P times 1 plus R divided by N raised to the NT. This number here, whatever it may be, your rate divided by your N, that's going to be a positive number. And that will be a number larger than 1. And NT ends up being essentially a number, and then P is your initial amount, your starting amount. So you have already worked with exponential models. Compound interest is an exponential model. So as an example of this, and I'm doing this one specifically because it's there's a question in your homework that deals with this, and in case you like, if you didn't know this going in, it would be annoying to deal with. So let's say Springfield has a population of 3,414 people and is growing at a rate of 6% per year. Write a model to determine the amount of people after 20 years. Write a model, an exponential model, and I'll explain why that is the case. A model to determine the amount of people after 20 years. You can also do this one without using any mathematics. You would just have to multiply 3,414 by 1.06 20 times. So not wrong, and I would give you full credit if you did that on an exam. If this was a question on the exam, if you did 1.06 times 3,414 people, if you did that 20 times, you would end up with the right answer. But you could do it a lot faster. Solution. Now, why is this an exponential model? Because there is a fixed rate of 6% per year. But remember, that's 6% of the current population each year. So as the population grows, that 6% means more. So after like, if there's 1,000 people, after the first year, there's 1,060. But now there's 1,060, and 6% of that is more than it was before. It's not just 60 people now, there's a little bit extra. So that's why it's an exponential model instead of a linear model, because that 6% grows each year exponentially. So we can use whatever variables we want. My recommendation would be P for population and T for time, but however you want to do it. So I'm going to say let P equal population and T equal time, or years, or however you want to write it. So I'm going to claim that the population model P, so y equals AB to the X. Here, P is the total. What would the A value be? So A is the initial or starting amount. 3,414. That's right. Because that's the initial amount of people present in Springfield. Now, here's the tricky part. What is B? It's 6%, but it's not exactly 1.06 to the T. Now, let's talk about why.
Oh,
So try and think about it for a second. Why would it not be 0.6, 0.06?
if it's 0.6, it's dropping 6% every year.
Exactly right. And because remember, if your B value is less than 1, it would be decaying. But that is a way to ensure that you're correct. But the real reason is, think about it this way: 100% plus an additional 6% every year. So when T is 1, you're doing your 3,414 people plus 100% of that plus an additional 6%. Just like we did with sales tax, right? When it was like, if sales tax was 8%, you would multiply it by 1.08 to account for the fact that it's 100% of your total plus the sales tax. Same idea here. It's 100% of your people plus an additional 6%. So that's the reason why it's 1.06. 100% of the population. So if they said that the growth rate was 20% per year, it would be 1.20. Yes.
For the T, why is it not 20?
So that's the model. This is the model. Now we're going to use the model. So then what is P when T equals 20? That's converting the English statement into the math statement. We want to write a model to determine the number of people, the population P, when the time is 20 years. So T is 20. So P equals 3414 times 1.06 times raised to the 20th power. And that should give you 10,949.1605. So the answer should be, that's not the answer because we can't have 0.16 of a person. So we'll say that it's 10,948 people and one pregnant woman. She's growing 0.16 of a baby. She's about so 0.16, that's roughly 16% way done. So 40 weeks times 20% or 0.16. So what? I'm kidding. I'm of course kidding. You could we would just round this to the nearest person. But if you wanted to be really cheeky, I would give you full credit for writing this. And I would give you a lull on the paper.
You round down rather than
So no. I'm being absolutely stupid. So 10,948 people plus an additional, so 10,949 people.
Oh.
So the correct answer should be roughly 10,949 people.
If it wasn't growing at a rate, that would it be 0 or 0.06 instead of 1.06?
Say it again.
If it were decreasing versus growing, would it be 0.06 or 0.06? Sorry.
That's a tough question.
Yeah.
Yeah. So if the population was decreasing by 6% per year, it would be 0.94 because it would be 100% of your people minus the 6% that are going away. So it'd be 0.94. Good question. Very good question. But so, yeah, you could I guarantee you if on the exam you wrote 10,949 people with one of them pregnant, that would be hilarious. And I'd have a great time laughing at that. But I will say on the exam, if this is a problem on there, I say round to the nearest person. So, yes.
So in the example, it says write a model. So do we also say the questions on the exam says?
Yes. So I promised you on an exam, I would break this up into two parts, or I would just, I probably would either say just find the amount of determine the population after 20 years, or I would say part A, write an exponential model, then part B, find out the population after 20 years. That's how I would write it instead. Any questions on that? So exponential models are a little bit harder to create on your own, but the thing is there are plenty of real world applications that involve exponentials. Population modeling, as we just saw, but biologists who study the field, they love to study exponential growth. Technically speaking, it ends up being no population growth is truly exponential. It's not like bunnies will overtake the worlds, right? They can't keep growing indefinitely. They will eat all the resources. So if you're curious, they have a thing called logistic growth. So it looks exponential up until a point and then it levels off and their population stabilizes. That would be the biology model. They call it logistic growth, but it is exponential up until a point. It's cool, but a lot of like, there's another one that's very, very useful. Is Newton's law of cooling, if you've heard of it. Newton, pretty big guy, pretty important. He figured out how to determine the temperature after a certain amount of time. Given like a hot thing or a cold thing in a temperate room, how long will it take for them to become in equilibrium, for them to be the same temperature? So a coffee cup, a cup of 205-degree coffee. So this is clearly not a latte for any of my baristas out there, because you can't get your milk above 200 degrees, otherwise it burns. So thank you, Starbucks, for that information. Thank you for my barista knowledge. A cup of 205-degree coffee on a table in a 72-degree room loses approximately 15% of its temperature per hour. Sorry, per minute. Until it reaches room temperature. Pretty cool if you think about it. It's like that, like, it won't go below that, because the room, like, then they will be in equilibrium and they will no longer get lower or higher. They will stay at that same temperature. And in a weird situation, technically speaking, that coffee cup is affecting the temperature of the room. It's just very, very negligible. This can be modeled by T equals 133 times 0.85 to the M plus 72. What is the temperature after 15 minutes? The temperature after 15 minutes. Now, technically speaking, I would have written where capital T is the temperature in American degrees, so Fahrenheit, and M is measured in minutes, but I didn't want to make us write any more. This problem's already long enough. But I promise you on the exam, if this was a problem, I would write where T is measured in degrees Fahrenheit and M is measured in minutes. Ah, why the 133? Where would that number come from?
15%.
The 15% is the 0.85, because it's 100% of the temperature minus 15% of it. But why is it 133? Yes.
Did you subtract 205 from 72?
Yes, that's right. That is the temperature difference in them. So like there's a formal formula for the Newton's law of cooling. We're not going to get into it, but basically it's the ambient temperature is the constant that ends up happening. Then you have the difference in temperature here. And so because like without getting too into the math, as M goes to infinity, as M gets larger and larger, this will become 0. If you don't believe me, just take 0.85 and raise it to the 50th power, and it'll be basically 0. So that all your 133 degrees in temperature difference is going away. So it'll eventually, if time goes on forever, this will like that will go away, and your coffee will be at 72 degrees. So that's how the formula works. But we're given the formula, luckily, and I will not make you memorize the Newton's law of cooling. If this problem shows up, I will give you the formula. And just being able to interpret the variables is the key thing here. So the solution, to think about it mathematically, we are saying, what is T when M is 15? That's what we're asking. What is the temperature after 15 minutes? When is T when M is 15? So we just plug it into the formula. So T equals 133 times 0.85 raised to the 15 plus 72. And so that's going to equal, and I didn't say what to round to, but let's round to the 2 decimal places. 133 times 0.85 raised to the 15 plus 72. You should get 83.618111 da 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 on forever. So roughly 83.62 degrees Fahrenheit, which my son would argue is still too hot. He's just saying it because he wants to disagree. He's drank 120-degree hot chocolate. But being the little scientist he is, he wants me to grab the thermometer to check it. You do it one time, and then he wants it every time. There's no subtraction with toddlers. As soon as you give like a little song at bedtime, now every time has to have a song. And you accidentally say some stupid thing when you're leaving the room, and now you have to say it every time. It's ridiculous. Toddlers are ridiculous. They're so silly.
Okay.
Do you get like any questions on this one?
Thanks.
You okay? Are you not getting the right answer? Like,
It's because I need to.
It's 'cause
break
it's
it down,
adding-
for
when it
instance,
says-
since we cannot broke this down, right?
Did I plug it in? So let me put it up on the screen so you can let me put so people watching the recording, sorry, you can always talk to me directly, but I want to show you what I put into my screen. Onto my calculator this.
And then to the 15.
I just don't know if I did put it in correctly.
So that's what I ended in my calculator. So 133 times. Technically speaking, if I wanted to be very, very careful, I'd put parentheses.
It's doing 15 plus 30. Yeah, yeah,
That's what
I
I
don't know
would like.
how to get it, I don't know how to get it to look like that, that's just mine.
But that'll be it for today, guys. We'll finish off. There's one more thing left for this thing called the rule of 72, but we'll get to that later.
Yeah,
All right.
if there's more after.
If you guys have any questions, feel free to email me. I'll try to make sure you're practicing the problems, getting prepared for the upcoming exam. Okay, guys? Otherwise, I will see you guys on Thursday. And if you guys have some other questions, I can help.